I'm Jason DeRuver with the Michigan Department of Transportation. Today I'm going to share a little bit about our thin epoxy overlay program that we have in Michigan. You can see here that Michigan is split into 7 regions. Each region has at least one bridge crew, as you heard from Tom Donnelly. Some regions have 2. I work in central office in Lansing. One of our central offices called Field Services. Basically responsible for, I develop all the training for our direct force bridge crews, make sure that our construction specs are in alignment with what our direct force bridge crews are doing and vice versa. I'll trial all of our new bridge maintenance products and basically make sure that construction maintenance in all the regions are in alignment on what we're doing and how we're doing all of our bridge maintenance. Just a brief outline, we're going to talk about the history of thin overlays in Michigan, what we do to scope a thin overlay, how we developed our specifications, our field step-by-step process, how we ensure the results, and if there's any time left, a brief question and answer period. We've been using this thin overlay since the early 1990s. This has just become another tool in our toolbox. It's nothing special. You know, I had to go out and give a similar presentation to the Montana DOT because they've never done a thin epoxy overlay. So, you know, I was trying to get them comfortable with it to tell them that this can develop into something that you just go out and do as a regular part of your bridge maintenance. We've come a long way. I love these old pictures where you don't see anyone wearing safety gear or stuff like that. This used to be very, very labor intensive. We were dispensing aggregate by hand, pulling the aggregate out of bags to cover it up. Everything was mixed in 5-gallon pails, and if you've ever broadcast aggregate by hand, you end up with so much extra that we were actually shoveling it back into the bags when we were done. So it was pretty labor intensive, but like I said, this is a long time ago, early 1990s probably. We also used to measure and mix by hand. Since then we've moved to a mechanical dispensing equipment, so take some of the human error out of it, some of the contact you might come into with the epoxy. You don't want to touch the stuff, and the more you handle it, the worse the material is for your health. So this is our first iteration of moving away from the hand broadcasting. We used a Venturi system. So everything was run by an air compressor, and the Venturi would be buried in the super sack of aggregate sitting in the back here, sitting on the truck here, but it still had to be, you know, still a little inefficient. It took 2 people broadcasting aggregate, and we've refined that down to 1 with the system I'll show you here in a second. And you still had this person back here that had to play around with the end of the Venturi tube and make sure it was still buried in the aggregate all day, and you're only pulling out of 1 sack, 1 2,500-pound sack at a time. Today the mixing is all mechanical. Aggregate is placed in a blast pot. We can get, I think this blast pot holds 4 or 5 super sacks of aggregate for us, and our labor force is greatly reduced. We can get 4 totes of epoxy on here at the same time. And you can see we've only got 1 person broadcasting aggregate, and it's actually placing even more aggregate quicker than the old Venturi system. Since 2006, MDOT state forces have placed 1.7 million square feet of thin epoxy overlays on our bridge decks. And we also use this. We also contract this activity out, and we've contracted out 3.2 million square feet of thin epoxy overlays. Like I said, this is just a regular tool in our toolbox now. We think it's very cost effective, and we have it very fine tuned. When we scope a thin epoxy overlay, I like to see any deck 1 year or older. I just say 1 year or older. Let it go through a cycle of a season of temperature swings. If the contractor had anything wrong with the concrete when they placed it, that should be starting to show, because once you cover it, you're not going to see your concrete deck anymore. Any deck bottom with a rating of fair or better, if you're starting out with a poor deck bottom, this isn't an application for you, because in Michigan we expect these to last about 15 to 20 years. And any deck surface with a condition where you only have to do a few patches, but if you have several patches that are needed where you might be switching to a concrete overlay, then obviously do the concrete overlay. And I'm not calling this a high friction surface treatment. We have a different spec for that, but this will increase the skid number of your deck. Our Michigan average tined bridge deck is a skid number of 40. And with the aggregates we use just for our thin epoxy overlay, we can get up to a 65. It'll also restore an older deck that's been polished by snow plows over the years. Building a successful specification, we started with the ACI 5033 specification for producing a skid-resistant surface on concrete. And then just with our own experience and Michigan conditions, we tweaked it from there, but our specification is similar, very similar in gradation, hardness, preparation, and moisture test. Our first deviation, though, was in hardness. The specification calls for a Mohs hardness of your aggregates to be 6. Our snowplow blades in Michigan have an equivalent Mohs hardness of 7, and when we use less than a 7 Mohs hardness aggregate, they actually polish rather rapidly. So we have upped our specification to have the Mohs hardness of 7 or greater. Surface preparation. The spec was real loose on surface preparation. It just said free of loose and unsound material. So we really dug into that, and we went into the ICRI guidelines for the concrete surface preparation. And Michigan, we use concrete surface preparation 7 or greater. The spec only calls for, I think ICRI states only 5 for thin overlays, but our experience is with the next item, the pull-off test, is that if you get a 7 everywhere on your deck, you really don't need to do a pull-off test, and we don't require our contractors to do it. In our experience, the way this other people set up their specs, the contractor has to clean one spot, and then you do a pull-off test on that spot, and that ensures that they know how to clean it properly to get your pull-off test, and then they're supposed to clean the deck the rest of the way that they did in that one spot, and that, that can be a little sketch. So we just say CSP of 7 everywhere on our deck, and we don't have any pull-off failures if we get that. You can see here removal methods. You can't even hardly see this, but this is just ICRI gives guidance on how you remove the concrete to get the different CSPs. You can get a CSP 7 with just shot blasting, and that's what we use in Michigan. We don't use any of the impactful methods. We all know about micro cracking, so if you're going to scarify or rotomill your deck, you're still going to need to shot blast when you're done to eliminate. That'll actually peel off the loose concrete, the shot blasting will, that was caused by the micro cracking. And then the keynote that I get from the moisture test for ACI 5033, and it says evaluate moisture content for concrete by determining if moisture will collect at bond lines between concrete and epoxy coating before the epoxy has cured. So what does that mean? To me, that means the moisture test can't be done with a moisture meter. You can't say it has to be below a certain percentage. You can't do it by stating a duration of doing an exact duration in your specification of saying, you know, tape your 4x4 sheet of plastic on the deck and for 2 hours, and if there's moisture, then you can't do it. You can't say that. Your time has to be based on the product that you're using for your moisture test and the atmospheric conditions on the day that you're doing the test. And you have to at least tape it off for the amount of cure time expected by the manufacturer. And that has to be off of their technical data sheet or talking to the rep. I know contractors will like to say, well, let me just run a gallon of it into a coffee can or something and see how fast it reacts. Well, it's a very exothermic reaction, and it's going to set, and a gallon of it in that coffee can is going to set much, much faster than it's going to set on your deck. So you have to do your moisture test for the duration of what the manufacturer says. And then this is the key, surface preparation. This is actually off of, this statement is off of one of the technical data sheets for our approved epoxy suppliers. Surface preparation is everything for the long-term performance of the epoxy overlay. All soft weak surface mortar must be removed to allow the epoxy to bond to the aggregate. So surface preparation is everything, and the epoxy has to bond to the aggregate. It doesn't say bond to the paint lines. It doesn't say bond to the cement paste at the top. It says bond to the aggregate. So we take that very seriously, and that's why we get the CSP7, because that exposes quite a bit of aggregate. In Michigan, additionally, you must remove the deck tining. Our deck tining is wet installed, so when it's wet installed, it's going to push that aggregate deeper into the concrete matrix, and so our tining is not going to have that nice big aggregate in it to bond the epoxy overlay to. You know, like I said, you have to get rid of the all paint lines have to be removed. It's not going to stick to the paint. And if you have any unsound areas of concrete, if you're using a traditional concrete patching material, you need to, all the manufacturers will say they'll want at least 28 days of cure time. So you want to make sure you get your deck patching identified beforehand. If you're using a rapid set material, you're going to want to talk to the manufacturer of the epoxy and say, is this rapid set material I'm using compatible with your epoxy? Will it bond? So you can see by this picture that all the tining has been removed, paint lines, aggregate is exposed. Is that enough to go on? I say no. What you're going to want to make sure you have, and I can pass these around the room, I brought them, is the concrete surface profile chips. I drive around the state stopping in at epoxy overlay jobs all the time, and I always have a case of these in the truck with me to hand out to the inspectors. You can actually just lay down the CSP7 chip on the deck and verify, is this what I have? A couple of remarks on final preparation and cleaning after you get your CSP7. You're going to want to make sure that your joints are taped, your drains are taped. You don't want this stuff getting into your drain system, falling into the water below. I mean, if you look at this, the B component of the epoxy has got the little dead fish on the side of it, so you don't want that going into your water system. And the epoxy will harden in the joint, and it's really nasty to get out, and will shorten the life of your strip seals. Blow off the deck with dry, oil-free air for your final cleaning. Don't use brooms. Brooms are just going to force dirt back into your cracks that you just cleaned out with shot blasting. And check underneath your contractor vehicles. If you have a vehicle driving across the bridge to apply this material and it's leaking oil all over your deck, that oil is going to soak into the surface of your deck and is going to be a bond breaker. Installation day, it's minimum recommended temperature 50 degrees and rising. If there's going to be any kind of rain in the forecast, you can't put it in within the cure time or 8 hours after the cure time, depending on technical data sheets that you're using. You can't place the epoxy overlay that day. And if your shot blast deck gets rained on, that rain is going to be pulling particulate out of the air, and particulate's going to be washing onto your deck from the adjacent roadway. You're going to need to re-shot blast it. You've already got your surface profile of 7, so the shot blast isn't going to necessarily be to profile it, but it will be needed to clean it off again. Squeegee the epoxy as soon as it's applied to the deck. Just don't let it sit there in a puddle. It'll start to set up on you in a big puddle. We use 2.5 gallons per 100 square feet of deck for our first course as an estimating purpose, and 5 gallons per 100 square feet on our second course. Applying the epoxy, it's all dispensed out of a volumetric pump from the back of the truck you saw earlier. And the epoxy doesn't even mix until it gets to this white tube right here. So it stays on ratio in separate component A and component B until it gets here. And this length of tube is long enough to do the complete mixing of the epoxy and dispense it onto the deck. Use spike shoes while squeegeeing, and use notch squeegees that are notched to the manufacturer's recommended thickness. There's just somebody pushing the epoxy. We also liked in Michigan to puddle it up onto the curb line about 1 inch. And these are the spike shoes. If you're not wearing these, you're going to fall down, and then you're going to be flopping around like a dolphin trying to get back up because it's so slippery. I've seen it. Use of a pressurized blast pot quickly delivers the aggregate. You want to apply the aggregate. For estimating purposes, we'll say 3.33 pounds per square foot, but you want to apply the aggregate to refusal. You want to apply it until there's no wet spots. You want to have complete coverage. Epoxy doesn't stick to epoxy. Epoxy sticks to the aggregates that you're applying. So if you have places where you didn't have enough aggregate and it's cured and set up, you're not going to get the next layer to stick to it. Here's just another sample of the aggregate placement. Life expectancy, like I said, we're expecting 15 to 20 years out of our epoxy overlays. Some of our old flood coats, you can even limp along for a little while longer. If they start to crack, we'll use our healer sealer epoxy to crack chase them. And if there's a couple areas where there's bad surface prep and they've delaminated a little bit, we can actually pull that up and re-sandblast that little isolated spot and patch the epoxy overlay. When we take off the epoxy overlay, I know I said don't mill don't mill, but you have to mill to get the old epoxy overlays up. Even if they're completely polished and failed, they still are really tough to get up. So we have a fine tooth mill spec that we use for the removal of epoxy overlays. And again, afterwards, we'll still do a shot blast. This mill spec only calls for like the top 1/4 inch maybe of your concrete deck coming off. We also switched to a darker aggregate. It actually almost looks like an asphalt overlay when you're done, but it's an epoxy overlay with a Wisconsin trap rock on it. And we feel we're going to get a little better winter maintenance season. Our decks will stay warmer. Here's just a thermometer on the right where the concrete is bare, is 90 degrees, and the dark aggregate on the left is 106 degrees. This was epoxy that had been poured the day before, so there's no more exothermic reaction going on. So that's just from the UVs. Troubleshooting. If you're applying mechanically, it's not the end all. You still have to know what you're doing. Always, before you start dispensing, you have to dispense about a gallon of it into the bucket to get all the air bubbles out of the system when you start for the first time that day. And you're always going to want to turn your nozzle on and off over a bucket, because if you when you turn off your nozzle, the bee's has a much lower viscosity and will run out onto the deck by itself, and the A will stay in the tube. And any spots where you get bee puddling up on the deck will interfere with bond, will interfere with your mix ratio, and instead of setting up nice and hard, it'll be more like the consistency of like hot gummy bears. And it's still really hard to get off. Contractors hand mixing, again, puddles. We don't want puddles. Here's a good example of inadequate surface profile. I don't even know if the contractor on this job shot blast the deck. I mean, you can see tining, you can see oil stains. I mean, and you can see that the tining was not strong enough to hold the epoxy down because it was ripped right off. These are drip spots from a nozzle. They never set up. And ensuring a quality job, when in doubt, Michigan added a 5-year warranty to their specification for contractors to do this. It's my experience that if there's no problem in your thin epoxy overlay within the first 3-4 years, then it was probably adequately surface prepped, and then you're going to have a good epoxy overlay for 20. Safety, consult the SDS. I recommend respirators. Use common sense. Avoid contact. They're endocrine disruptors, and they'll build up in your system and become worse over time, so don't put your hands in it and play with it. And if you put a bunch in a bucket and it starts smoking and kicking, don't lean your head over thinking, oh, let me see what's going on here, because the vapors are bad too. Summary, thin epoxy overlay seals cracks in bridge decks by bridging them. They don't really penetrate. They've got about the same viscosity as honey. We use them on any deck, 1 year or older, or with a fair or better deck bottom condition. Increased skid resistance. Our dark aggregates that we're using now deter icing. They're very heavily dependent on surface preparation. And our, just for estimating purposes, our deck preparation rates to get a CSP7 are between 600 and 850 square feet per hour. And our placement rates are between 1,000 and 3,500 square feet per hour per layer for our epoxy overlays. I brought all of these documents with me electronically if anyone wants them. I have our thin epoxy overlay, bridge deck overlay specification, performance warranty specification, our removal specification. We have log sheets for our epoxy overlays that we make our field personnel fill out when they're placing it, that records like the time, temperature, aggregate, material used, so we have a good database of all that, performance. And I also we recently did a wear track polishing test with NCAT on all of our aggregates, and recently updated our flood coat white paper. Any questions?
Well, I got a question, 2 questions actually. Do you ever put your thin overlays down on new bridge decks? Within, appropriate amount of time of a new bridge deck? And second, would you mind if we downloaded your documents into the proceedings for the meeting?
No, that's fine. Yes, we do put them on new bridge decks, but like I said, I'd like to see them wait a year. So basically, we'll contract out a new bridge deck, and then if time allows and there aren't other fires to be put out, our regional bridge crew, direct force crew, will go out and epoxy overlay it the next summer.
As a follow-up to that question, how about how old a bridge would you put it on? In other words, do you do chloride ion testing other than doing the visual of a good or fair deck? Do you also
We don't do any chloride ion testing.
So if it looks good,
if the deck bottom is still good, we go for it.
What's the oldest bridge deck age that you've put these on?
I mean, all of our highway bridge decks that are still in good or like fair condition or better, built in the 50s and 60s, we'll still put them on.
That machine, do you guys own that in-house, the state that does all the aggregate spreading and mixing and everything else?
Yeah, this machine right here is an in-house machine that my engineers developed and bought all the parts for and put together.
How about one more question? Got one back here.
Jason, what kind of cost does the state see for a final product per square foot or per square yard to do an installation like that?
I haven't really tracked the for estimating purposes for our contractors. I believe it's $30 a square yard for this application. I want to say our in-house is doing it cheaper, just because I recently had the luxury of putting out a 5-year contract for epoxy purchasing for the entire state. So when the vendors saw that if they didn't get a low bid in, they were going to be shut out for 5 years, the prices came like really, 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 really low. Like, I don't even know if they're making money.
How about just one more question, and then we're going to go to break?
Thank you, Jason. That was a good presentation. One question I have, I heard you mention that you put a thin overlay on a 1950s deck. I'm assuming that's based on visual evaluation that deck is looking good. Is that right?
Yes. And
what kind of life you get when you put an overlay on a 1950s deck? Have you tracked that life?
I'm not sure about those decks. I know in our northern region, 2 summers ago, we took off a thin epoxy, we milled off a thin epoxy overlay that had been on a 1970 deck for 20 years, and there were no D-lams, and we put down another thin epoxy overlay.
All right, how about a big thanks for Jason?